Hey, it's Joel. We're here in Prague in the beautiful Czech Republic. We're here for Maker Faire. But what's also here in Prague is Prusa Research. And my buddy Joe at Prusa Research is going to take us on a tour, and we're going to find out how Willy Wonka makes the chocolate. We're going to do it right here on 3D Printing Nerd. Hey, Joe.
Hey, how's it going?
Good to see you. Hey, everybody, this is Joe Prusa right
Hi.
here. This is your factory. I've never been. I'm really excited to see everything. Can you take me on a tour?
Yes, of course. Right now we are on the second floor where we have the farm and the manufacturing. And I would say that we will start with the farm, right?
That's a great idea. I'd love to see that.
All right, let's go.
All right. Joe, this is amazing. This is your print farm right here.
Yes, it is.
How many machines do you have in this?
So right now we have 500 printers here.
500.
Yes.
That's amazing.
And there's around 400 more around the office. Yes.
900 printers in total in this building, just
Yes.
printing things.
Yes.
So these 500 are dedicated to the parts that go in the kits and the fully built machines, right?
Yes. That's how we make the parts. And it's roughly 30% of the machine, I would say.
Okay. What about these spools? These don't look like typical Prusa spools I would get.
Yeah, they are custom just for the farm. So we have a wider one, which can hold 2 kilos, so we don't have to change them as often.
Oh, okay.
Yes.
And the parts are printed in, is this PETG?
Yes, that's
Okay.
our own PETG, which is manufactured actually one floor below us. So when we actually finish up the spool, we take them down and they are wound again.
Is there a reason to how things are laid out in here? Are certain parts printed in certain areas?
So we have couple plates with different parts, and actually our ERP system tells the farmers which and how many of the plates they need to start when the print's finished.
Okay.
And these printers are actually connected to our ERP system through Ethernet, and they have modified firmware. So when the plate finishes, it asks the operator if it was a successful print, and because it knows by the name of the plate how many and which parts were there, it loads them into our inventories. They all have the same SD card basically, because it is just more reliable. But for example, we can flash the firmware via the Ethernet.
Oh.
Yeah, can you imagine when we have a new firmware to go and update 500 printers by hand?
It's tough. I mean, I know it's tough for me, and Sean, it's tough for you, isn't it? So you can do it all automated.
Yes, but it is, it's our internal system, but we are in the process of making it available to everyone. Basically, the farm management system.
Oh.
If you want to produce parts at larger scale, and if you want to have like 50 printers at your office, so we are in the process of making it a product. This place is actually very important for us, not just for making the parts, but we can really stress test the printers.
Oh, right.
Because they are printing a little bit faster than what we provide to our customers. Yeah, we are testing the harshest conditions, and actually with 500 of them and 24-hour a day printing, we have plenty of print time. So I would say that this is one of the main reasons why the Mark IIIs are so reliable. Because if we f something up,
You'll find it in here.
We find it very quickly.
Well, this is amazing, and I'm really happy we got to see this. It's getting a little warm in here since this is an active factory. What's next on the agenda?
So next, I think we are going to the extrusion lines.
Perfect.
Yes, to see how the filament is made.
I can't wait to see that.
All right,
I'll follow
let's go.
you. What is this room?
So this is the prep for everything. This is where the magic starts.
Oh.
So here you can see the bins of the virgin polymer, because we use only the virgin polymer. But basically what happens here that the filament gets loaded into the hoppers and gets dried, and then it goes to the lines. So over there you can see a molecular sieve, which is actually making the air super dry.
Okay.
And in the continuous hoppers, it just blows the dry air through them. So we have 6 lines, so there are 6 hoppers like that, and it's automatic feeder from the bin of the resin, goes on the top, blows the air through, and it takes automatically from the bottom to the line, which we will see in a second.
Okay.
And over there we have our cooling equipment, because we have 12 cooling tanks, 2 for each line, and the water gets circulated here and it gets cooled in the summer, it's working like an AC, so you could get down the temperature enough. But in the winter, it's actually not using the AC system, it's just cooling it outside.
Oh,
so
okay.
we can save a lot of energy. And what we are...
So it's a continuous cycle of water, keeping the temperature and the pH at a consistent level.
Yes.
Wow.
And all the 12 cooling tanks which we have here are connected to the system. All right, I think we can move on.
Perfect, I'll follow you.
Okay, let's go. So now we got into the actual extrusion line.
Okay.
So this part is called the extruder. You might have heard.
I've heard.
About extruder.
Yeah, once or twice.
But this is a little bit bigger extruder.
Yes.
But what is interesting is that we also have automatic hoppers here. The resin gets sucked from the drying hoppers.
Okay.
And that is just colorless resin.
Oh, this is how you make different colored filaments, is pulling the pigment from here, but automatically.
Yeah.
Okay.
And so what is special about this, that it's gravimetric. Usually, that means that it sucks the master batch in.
Right.
And it weighs it precisely down to 1/10 of the gram.
Oh.
To make the mix perfect. So when we make the recipe, it's always the same.
Oh, this way the spool 1 and spool 10 are the same color.
Yes.
Got it.
Yeah.
Oh, and there it is right there.
There's the filament. And this is our first cooling tank, which is actually quite warm. When the filament exits the extruder, you don't want to shock it with super cool water because it could deform.
Oh, so by having it not being super cold at the beginning, you're gradually decreasing the temperature.
Yes, that is the point. So we have 2 cooling tanks with each of the lines.
Okay.
So this is the warm one, and we are slowly getting to the cool one. And you can see that the warm one has water condensate on the cover.
Right.
But the cool one doesn't.
Oh wow.
Yeah.
What is this right here?
So it is, these parts are for getting the water of the filament.
Ah.
Yeah. But what is interesting is that even during the water cooling process, the filament doesn't absorb basically any moisture.
Oh, is it because of the time? It's not been there long enough?
Yeah, it's not there long enough, and as it's hot, it just gets out.
Okay.
But what is interesting here, that here we are continuously checking the color.
So you can verify that your automatic method back there is producing the same color all the time.
Yes.
Wow.
And also, if the master batch gets little bit diluted or something, we can check that it's exactly matching our recipe. And here after that is the laser, which checks the diameter from 2 sides at 90 degrees. Yeah, like that.
Oh, like that. Okay.
And by the readings from the laser, you want to change the diameter. But it's not actually done by speeding up or slowing down the extruder, because that has a lot of lag. So it's rotating at constant speed.
Right.
But the puller can pull faster, and it will make the filament thinner or slower, and it will make the filament wet.
And this is automatic.
Yeah, always closed loop system, basically PID. And now we are going to the accumulator.
This looks cool.
Yeah, what this is good for when you finish spooling one of the spools and you want to start doing another one. So you cut the filament, but it would be flying out.
So instead of the filament flying out, this it looks like it expands like an accordion almost.
Yeah, and it can hold up to 60 meters. So you have basically 1.5 minutes to start the new spool. And when you start the new spool, it just winds faster, and this gets closer together.
Okay.
After that, it's just winding the spool, and these are actually the spools.
Cardboard core.
Yeah. So we just make the standard spools wider, so it can hold 2 kilos for the farm.
Okay.
And as I said, in the farm, when they get used up there, they bring them down and they get refilled again.
Plus, I just have to point this out. You're eating the filament.
Yeah, I mean, it's an Easter egg when you finish a persimmon. But we had the line basically for almost a year before we even announced it. So we wanted to make it perfect. So, we just wanted to gain the experience. And as I was talking about the data, you know that every spool has the little QR code on it where you can check how it was made.
Yes.
You can behind you on the wall you can see the dashboard.
Right there.
Yeah. in this room there are 2 lines, and you can see 2 dashboards. You can see which recipe we are doing, and you can see the diameter in both axes and the average diameter from both of the axes.
Okay, and there's a tolerance per axis, right?
Yeah, there's a tolerance for the diameter and also tolerance for the color.
Okay.
And if any of that goes out of spec, actually you will not be able to put the QR code on the spool, so it never comes out.
Is that something you use internally?
Yeah, the auto spec spools we have them here for our employees. They can take them and print with them.
Oh.
But we also have them in the Prusa lab, so
I see.
so people can print with them because the filament is good, but it's not perfect.
I understand.
I mean, others are doing 50 microns. We are doing 20, so I mean, we don't want to completely throw away spool which is 30 microns, right?
Sure.
So we use it internally or in the lab.
Oh, perfect.
So Joel, welcome to manufacturing.
Manufacturing. I like it.
So well, this is the place where most of the magic happens, and when we get the material, it goes here. It gets tested, marked, and either packaged for the kits, or over there's a station where we do full assembled printers. And what we will do, I'll show you some of the stuff or some of the testers we do, and we can fully trace all the parts.
All the parts. So if
I mean, not nuts and bolts, but
Sure.
but extruders, electronics, heated beds. So when customer receives something bad or it doesn't work or doesn't last, we can backtrack it to the
Wow, that's great.
to the order we got from the manufacturer, and we can check everything. So I would say that we will start with testing of the electronics.
electronics. Okay, where's that at?
It's over there. Let's go. At this station, we are testing the electronics. It is basically the final test, but it is the most complex one.
But by electronics, you mean motors, fans, board?
Motors are tested separately, but
Okay.
you have the INC here, you have the extruder here, you have the heated bed here, you have the LCD screen and SD card. And basically what it does, it connects everything as if it's connected in a printer without building the printer. It flashes the firmware, it tests all the outputs, inputs.
Oh.
It actually tries to write to an SD card and read back from it. You have to test the LCD and everything. And these parts, when the test is finished, you get the serial number gets assigned to the board, and you get the silver sticker, and you get the test we include with a test report.
That paper report, right?
Yes, that's made here.
Okay.
And once that happens, all these parts go into one box, which is again also tracked around the factory, and they are never separated, and they go together to one kit. Because they were tested together and they know that they work together.
Right.
You just set which product it is. In this case, it is the Mark 3S kit, and INC is inserted, and you see that it cleans the board.
Look at that. And this is it. This is just going to go through its test procedures, right?
Yeah, it will go through the test procedures, and it tells the operator what it should do. And also, what happens here is it heats up the extruder. And we are doing the final tightening of the nozzle against the heat break here.
Okay.
Because you need to do that when it's at operation temperature.
Right.
Otherwise it will be leaking. So I guess that's it, and we can go to the next station.
Let's do it.
So right now we are at the PINDA testing station, which is our induction mesh bed leveling probe.
Right.
And we need to test all of them. And basically we made a tester which where you put them in, and it measures the sensing distance, it heats them up, and it measures it again. So you know when the printer is printing and everything is hot, it needs to have the same distance. And yeah, that is how it's done. And you can take a look. So this is the first part of the assembly of the nozzle. We have also tools to make everything right. It's being pre-tightened because the final tightening of the nozzle is done at the test station.
Over there.
So now we are at the second station where the nozzles get the connectors and PTFE tubes, and also they get marked with the QR code. So right now we are at the power supply test station. Even though we upgraded to the Delta power supplies, which makes them custom for us. And it's pretty reputable manufacturer because they are doing all the chargers for MacBooks and Apple products. But we still want to test everything. So each power supply gets plugged and tested if it works at 240, 110. And also what happens because the power panic circuitry is embedded in the power supply, it also tests how long the caps can last if the power panic functionality will be working. So each of them gets unpacked, plugged into the station. The test takes roughly 9 seconds. Then when the test finishes, he scans the label, which also has unique ID, and it gets slapped to the power supply as a sticker.
And then it looks like he seals the bag with the label.
Yeah. So
it travels with everything.
Yeah, so you couldn't mismatch them.
Right.
So we have a lot of custom machines which save us a lot of time. So for example, this is our PTFE cutter. We have 2 because we have to cut a lot of PTFE tubes. We are bundling some spares with the printer. And basically this was, before we made this machine, it was 3 people just cutting PTFE tubes all day, every day. This machine does everything automatically and just spits them out. You set the length and it just does it all day. So Joel, this is our kitting station where we pre-count all the nuts and bolts and other parts for the kits.
Got it.
So you don't have to count them yourself. So every bag is tracked. Every bag has QR code on it and we know the weight of all of the bags.
Each bag is done by weight, so you don't have to count individual parts. You can put parts in and you know how much it should weigh.
No. You count them, which is more precise. But when you have the final bag, we weigh it. And that is another check.
Okay.
And each bag has a unique QR code, and we know the exact weight of every bag and who bagged it. So this is where we check the heat beds.
Okay.
Again, every single one is checked, and you have a little QR code, so you know who checked it, from which batch, from which manufacturer it comes.
Okay.
So if we have some warpage or something, we can track it again back to the order from the manufacturer. We are actually using multiple manufacturers for the beds because they are pretty hard to make.
Yeah. If you need a big batch of them, rather than having one source, you have multiple sources. Why is he smacking the bed?
To get rid of any dust or particles because they are checked on a calibrated granite plate. And always you have like tolerances which it needs to hold, and if there's something stuck on the bed, it will wobble and throw away the test. So this is actually where the final process in the factory, where everything gets packed and scanned from the boxes which were touring around the factory into the final box. You can see it on the screen that the parts which get into the box get green. So the order cannot pass without all the boxes going green. All the parts are matched to the order, so we know which goes where and nothing gets lost, and we are sure that everything is in. So right now we are at a place where we do the full assembly printers. So you can see some sub-assemblies around us, because we don't do it like you build a kit. We have someone who just builds the x-axis, someone who just builds the frames. So it gets more efficient, and then at the final station they take these parts and assemble the full printer. And the final assembly is somewhere around 1.5 hours for the thing, which is much faster than if you build it yourself.
I can do it in 5 hours.
Really?
Yeah.
You need to do better. Next time I'm in Seattle, I will walk you through the process.
Okay, deal.
You can take a look here, and then we can go to see the final assembly over there. So this is where the final check is done, where the printer gets tested, and it will eventually print the test pattern which all of the printers which are sent to customers have. There is a rack full of those which are fully done and ready to go to the shipping department.
This one's ready for shipping.
So Joel, welcome to our SLA assembly.
SLA, this is the new one, right?
Yeah, this is where we build the original Prusa SL1.
Okay, this is your SLA machine, and it's an MSLA machine.
Yes.
Right, mass SLA.
Yeah, basically you shine through an display, and where the light shines through, the photopolymer gets polymerized and hard.
Oh, perfect. And it's shipping now, so I mean, this is
Yes.
where you put it all together.
Yes, this is the production. So let's take a look at some of the processes and how it's finished.
Yes, let's do
Good.
this.
So this is where some of the assembly is done. For example, this is where we make the vats, and this is where we assemble the air filters
Oh,
to
okay.
remove the fumes.
The vat being where the resin goes.
Yeah. Basically, we are assembling to the aluminum block. We are assembling the FEP foil, and now we are looking at our clean room where we assemble the LCD. And you don't want to have any dust specks in the LCD assembly because it could affect the quality if you would have dust caught in there. So we are not only making the SL1s here, but we are also doing the curing and washing station here. Just
The CW1.
Yeah, CW1. And you can see the assembly of that just behind us. And this is where the final magic happens.
Final magic.
Yeah, after checking all of the parts, again, same as with the FDM printers, the parts go here, and we have 6 stations where they build the final SL1.
Oh, so after it passes through these 6 stations, then it's it. You have the product. The SL1, it is ready.
Well, after it passes this place, it goes to the testing because as it's a new product, we are testing and doing at least 24 hours of a print on each of the printers, so we know that it's perfect.
Oh.
And if it's not, it goes back for a rework.
Yeah, I see rework right there.
Yeah. And this is our Prusa lab.
This is amazing. Look at all these machines just
Yeah.
printing stuff.
Yeah, we devoted one floor in our factory to do this, so we can kind of give back to the community in Prague. So, I mean, when I was in college and I wanted to hack and I was in the dorm rooms, I just couldn't because there was no place. And I remember that, so I wanted other people not to have to experience that feeling that they want to make something but they don't have a place.
So this is a place for people to come and make things.
Yeah, so we are in the printing section.
Sure.
Where you can see our Mark IIIs, SL1s, but also we have a laser, wood router, big Haas CNC mill, big Haas CNC lathe.
Oh, wow.
We have electronics place, and we have like mechanical workshop. So you can do pretty much everything, and we also have a place where you can do talks and where we have parties.
There's always parties.
Yes.
What does it take for someone to be a member of Prusa Lab?
Just go to prusalab.cz and you see all the memberships and stuff.
Oh, okay.
Yeah, they are being worked on right now, so you can check what is the latest.
Yeah, it looks wonderful. I mean, it's a lot of space. It's very open. It looks like it really encourages collaboration.
Yeah.
And I'm willing to bet the next few years we're going to see some amazing things come out of this place.
Yes, we have some pretty cool projects. You can take a look later.
Sure.
All right, so I guess that was the tour of our factory. This is our main building. We have 2 more in this area, but they are just mainly warehouses. We have 1,700 pallet space warehouse.
That's huge.
And we also have a secret lab where we make the PEI powder for powder coating, and we are starting to develop our own SLA resins.
Oh,
Yes.
so not only making your own filament, but making
Yeah.
your own resins.
Yes.
I'm really glad that we were able to come out here. A big thanks for bringing us out. That was awfully kind of you.
You're welcome. It's a pleasure.
And I hope this isn't the last time I get to see your lovely face
I hope so
here
too.
in Prague.
And see you at Prague Maker Faire.
See you at Prague Maker Faire.
High five.
Do you like it?
I love it!
Oh, this is wonderful.
No! Don't do the Fortnite dance! Don't.